Hello friends, I welcome you on my channel Engineering Mathematics djganit. The purpose of starting this channel is to provide free coaching of each mathematics subject. So I welcome you in my new lecture series on calculus. In this lecture series we are going to discuss different concepts of calculus one by one. So today we are going to discuss the limits of functions of several variables or limits of functions of more than one variables. You have studied limits of functions of one variable in your school. You have seen this type of limits in your school level, and now we are going to extend these limits to functions of more than one variables. Suppose we consider function of two variables x and y. Then the domain of this function will be some region in xy plane. Suppose this is the domain D of this function fxy. So suppose we consider some fixed point, say AB, and we want to determine that if these xy points in the domain are approaching this fixed point AB from any direction, then we are interested that function will approach which real number. So that we can denote by limit of fxy as order pair xy approaches order pair AB. So order pair AB is a fixed point in the xy plane, and we are interested in the behavior of this function of two variables xy whenever xy is approaching this fixed point in xy plane. So the definition is same. The definition for single variable function and multivariable function is same, but the generalization is little bit conceptual for this limit of functions of two variables. For example, if we talk about limit of function of one variable, then the domain of this function is some interval on the real line. So this fixed point A is on the real line. Suppose A is somewhere here. So here, to approach this fixed point A, there are only two possibilities. Either we can approach this fixed point A from left hand side, or we can approach this fixed point A from right hand side. So if the limit remains same along both the paths, then we say that this limit exists. So that is known as right hand limit and left hand limit. So if these two limits exist and both are equal, then their equal value is nothing but limit of this function fx as x is approaching A. But for functions of two variables, the domain is not on the real line. The domain of this function is somewhere in the xy plane, and this fixed point is now some point in the xy plane. Suppose AB is a fixed point in the xy plane. So we are interested in the behavior of this function fxy as xy is approaching this fixed point AB. Now in contrast to this case, here there are only two possibilities. Either we can approach A from left hand side, or we can approach A from right hand side. But here, to approach this point AB, there are infinite number of paths. We can approach AB in this direction, or in this direction, or we can approach in any path in the xy plane. So there are infinite number of possible paths to approach this fixed point AB in the xy plane. And the definition is, if this limit remains same along all possible paths to approach this fixed point AB, then we can say that limit exists. And here it is required to check limits along only two paths. If limit remains same along two paths, then we can say that this limit exists. But for this limit, we have to check limit along infinite number of possible paths approaching this fixed point AB. So we will see how to evaluate this type of limits, or how to decide whether these limits exist or not. Now if we want to show that limit does not exist, then it is easy. Why? Because if limit exists, then the limit must be same along all possible paths approaching this fixed point AB. But to show that limit does not exist, we have to find out at least two paths approaching this fixed point AB, such that limit is different along those two different paths. So first we will discuss the examples in which we will show that how to prove that limit does not exist, and then we will discuss those type of problems in which limit exists, and we will see how to show that limit exists. So our concentration first is on non-existence of limit. So for non-existence of a limit, we have two-path test. Two-path test for non-existence of a limit. So what this test says, if we can find out two different paths, if limit of fxy as xy tends to AB is different along two different paths, which approach this fixed point AB. Approaching point AB, then the limit does not exist. Okay, so now we discuss how to show that limit does not exist using this two-path test for non-existence of a limit. So we consider one example. Check whether limit of x minus y over x plus y, where xy is approaching 0, 0, that means origin, exists or not. So here our function is x minus y over x plus y, and the fixed point at which we are interested in the limit is origin. So suppose this is xy plane, this is our fixed point origin. Now there are different paths to approach this point origin. So we will check limits along different paths, and we will find out two different paths along which limit is different. So suppose I approach this point 0, 0 along positive x-axis. Suppose I consider this path. So along positive x-axis we know that y is always 0, and because we are along positive x-axis we consider x positive. So first we check the limit along this path, along y equal to 0, x greater than 0. So we can write in this way: limit of x minus y over x plus y xy approaching origin, and in the bracket along y equal to 0, x greater than 0, and along this path we check what is the limit. So along this path y is 0 and x is positive. So if you put y equal to 0 here, limit will be limit x tending to 0. We put y equal to 0. So this is now limit x tends to 0, x over x. But we can cancel out x because x is positive along this path. So we have seen that if we approach this origin along positive x-axis or along y equal to 0, x positive, the limit of given function is 1. Now we check the limit along positive y-axis. That means along this path. So along positive y-axis, we know that x is 0 at any point on y-axis, and because we are going in this direction, y is positive. So now we examine the limit along positive y-axis. So limit of x minus y over x plus y, xy tending to 0, 0, along positive y-axis, x is 0. So along x equal to 0, in the bracket y is positive. So along this path we have to put x equal to 0. So if you put x 0, limit is converted in terms of y. So this is 0 minus y over 0 plus y. So this is now limit y tending to 0 minus y over y, but y is positive, so limit is minus 1. So what we observe is, if we find limit along positive x-axis along this path, then limit is 1, and limit along positive y-axis is minus 1. So we have find out two different paths along which limit is different. So we can write the limit is different along two different paths. The limit is different along two different paths approaching 0, 0. So therefore limit does not exist. Limit x minus y over x plus y, xy approaching 0, 0 does not exist. Now it is not necessary that you consider only these two paths. You can consider different paths also. Suppose I consider the path y equal to x. If I consider the limit along this line passing through origin y equal to x, then along this path if I put y equal to x, limit will be 0. So that is also different from those two different limits obtained, which are 1 and minus 1. So the only thing you have to do is, you have to just find out two different paths along which limit is different to show that limit does not exist. Now another way to do this example is, suppose you don't want to write down two different paths, then what we can try is, we know that the equation of straight line passing through origin is y equal to m into x. Okay, any line passing through origin is having equation y equal to, suppose this is y equal to x. If I consider another line passing through origin, then it is y equal to 2x. Suppose this is y equal to minus x. So if I want to represent all the lines passing through origin in a single equation, then I can write y equal to m into x, and for simplicity I can write m not equal to 0, because if m equal to 0, then we have y equal to 0, that is only x-axis. But if we want to represent all the lines passing through origin, then we can write y equal to m into x. M is non-zero as well as x is non-zero. So this equation represents all the straight lines passing through origin. So if we consider y equal to mx in given equation, if we wish, we can find out limits along all possible lines passing through origin. So here, suppose we try to find out limit along all the lines passing through origin. So we will put y equal to m into x. M is non-zero, x is non-zero, and we see what happens. So we put y equal to mx, so we will have x comma mx tending to 0 0. So we can write one more step. We put y equal to mx. So this is x minus mx divided by x plus mx. Now from this we have x tending to 0. This second implies m into x tending to 0. So we can see m is non-zero, and from this we have limit x tends to 0, and here we can cancel out x because x is non-zero. So we are left with 1 minus m over 1 plus m. We can cancel out x. Now there is no x term here, so it is constant, and limit of constant is constant itself. So here the limit along any line passing through origin y equal to mx is 1 minus m over 1 plus m. But if you observe, this answer of this limit is function of m. It depends on m. For example, if we want to find out limit along y equal to x, we have to put y m equal to 1. So for m equal to 1, limit will be 0. If we consider this line y equal to 2x, we have m equal to 2. So along this line, limit will be 1 minus 2 upon 1 plus 2, that is minus 1 by 3. If we take y equal to 3x, that means limit along line y equal to 3x, then we have to substitute m equal to 3. So it is going to be 1 minus 3, that is minus 2 by 4, which is minus 1 by 2. So from this you can have the idea that if the answer of limit depends on m, that means the limit is different along different values of m. That implies that the limit is different along different lines passing through origin. So therefore limit does not exist. Because limit exists, then it must be same along all possible paths. So this is another way to write down the same problem. Either we can write by finding out two different paths along which limit is different, or we can go in this way. here we have find out limit along all possible lines, and if this answer depends on m, which is different for different values of m, therefore limit does not exist. Now if the answer does not depend on m, then limit will be same along all possible lines, but that also does not mean that limit exists. In that case you have to check limits along another possible paths like parabola, y equal to m into x square or x equal to m into y square. These are the general forms of parabolas passing through origin. So if limit is same along all possible lines passing through origin, then we have to check for another type of curves passing through origin. But if limit is function of m or limit depends on m along different lines, then limit does not exist. So from this we can say that 1 minus m upon 1 plus m is different along different, or is different, which is different for different values of m. Which is different for different values of m. Therefore the limit is different along different straight lines, because for different values of m we will have different straight lines. So the limit is different along different straight lines passing through origin. So therefore limit does not exist. Limit of x minus y over x plus y, xy tends to 0, 0 does not exist. So we consider one more example to check the limits. But now onwards we remember this note to check the limit of fxy as xy tending to origin. We will check the limit along this type of different paths. First we will put y equal to mx, m is non-zero, x is non-zero. So these are the different paths which we will follow. First we will check the limit along straight lines passing through origin. If the answer depends on m, then limit does not exist. Now if answer depends on m, then we will check along y equal to m into x square, which is parabola. So either m is non-zero, x is non-zero. If limit depends on m, then limit does not exist. But if limit does not depend on m, then limit is same along all possible parabolas, but it does not mean that limit is same along all possible paths. So we will try for this type of parabola, x equal to m into y square. M is non-zero, x is non-zero. Then again we will check. Now if we are getting the same limit in path 3 also, then we can think for this cubic path passing through origin. So if we are getting the same answer along all possible paths which we have shown here, then there are chances that limit exists, and that common value may be the limit of a given function. So from this we can have the idea that whether limit exists or not. If we are getting the same limit along all different paths 1, 2, 3 and 4, then we may have the idea that there are chances that limit exists, and we will try to prove that limit exists using the definition. And if limit depends on m along by putting any of these paths, then limit does not exist. Now if limit is same along all possible lines in path 1, and suppose value of limit is say L1 along all possible lines in path 1, then we have to check limit along all possible paths which are parabola. If suppose limit is L1, then we have to go for next possible paths. Now suppose limit in path 1 is L1 and limit obtained in path 2 is L2, and if L1 and L2 are different, then also limit does not exist. But suppose we are getting L1 here, then we have to check along third path. If we are getting different limit from these previous two limits, then limit does not exist. Suppose we are getting the same limit, then we have to go for a next possible path. So in this way we can check along different paths passing through origin, and from this we may have the idea that whether limit exists or not. And if limit exists, if there are chances that limit exists, then we will prove the existence of limit by definition, which we are going to discuss later. So now we take one more example on how to show that limit does not exist. So we consider this limit, a limit xy tending to 0, 0 x over square root of x square plus y square. So here also we can check either along x axis or y axis, but we will not go in that direction. We will check along different paths. So first we check the limit along y equal to mx, that is all possible lines passing through origin. So first we check along this path. So along this path, limit xy tending to 0, 0, function is x over square root of x square plus y square. So here we put y equal to mx, so limit will be x tending to 0, x over square root of x square plus y equal to mx will give us m square x square. So this is now, here we can take x square common, and square root of x square is x. So we have square root of 1 plus m square. Now x is non-zero, so we can cancel out x, and we are left with x tending to 0, 1 over square root of 1 plus m square. So there is no x here, we cancel out x because x is positive or x is non-zero. So here we write x is non-zero. Now this limit is independent of x, so limit of square root of 1 plus m square is 1 over square root of 1 plus m square. So you can see here the answer depends on m. So this means that the limit is different for different values of m. That means the limit is different along different lines passing through origin. So therefore limit does not exist. X over square root of x square plus y square does not exist, because the answer depends on m. That means for different values of m we have different straight lines, and hence the limit is different along different straight lines. Therefore limit does not exist.